For nearly 60 years, astronauts have been looking down at Earth from space. And all along, they've been shooting photos. They've been doing so almost daily since November 2000, when the International Space Station became a permanent home to astronauts. Like everything the astronauts do, they are trained for this job, to look at our planet and chronicle what they see. They don't look at Earth and take photos just for the novelty, though there is definitely beauty, joy, and inspiration in it.
So it's not just for fun and make them feel comfortable. There's real use to it.
Space can be disorienting, so the astronauts are trained to orient themselves to their planet as they float above it.
Welcome to Tournament Earth, or how we at NASA Earth Observatory do friendly competition. This year, we featured images taken by astronauts on the International Space Station, making this competition literally out of this world. 32 images were selected by astronauts, NASA staff, and you, the public, but only one can be crowned the champion. We're about halfway through the tournament, so let's take a look at what's going on. At the end of round 2, all #1 seeds have been eliminated. Perennial favorite, the Sarchev Peak eruption, was also eliminated in round 1. Little known fact, this image of one of the most active volcanoes in the Kuril Islands actually became in 3rd for the Wikipedia Commons photo contest in 2010. Heading into round 3, we still have a lot of strong contenders that can take home that trophy. The Susquehanna River, taken by astronaut Christina Koch, actually rolled over 2 very strong opponents. The number 8 seed knocked out the number 1 seed Lake Powell in the first round. Then it narrowly edged out checkerboarding in northern Idaho. Looks like that image will not be getting kinged anytime soon. Next, it faces the Castellanus Cloud Tower, a massive vertical cloud formation associated with thunderstorms. The name Castellanus actually comes from its similarity to turrets of medieval castles, and it might need an army to conquer the river and mountains. On the same side of the bracket is Lake Van, which is another Cinderella story as a number 8 seed. This photo of Turkey's largest alkaline lake was taken by astronaut Kate Rubins and has been knocking off our nighttime imagery. In the first round, it turned off the lights for the number 1 seeded fishing boats. Then, it made Elba disappear like a ghost in the night. Next, Lake Van faces a tough opponent, Typhoon Maisak, which received the most votes in round 2. Moving to the other side of the bracket, we have a very exciting match to watch. 2 stellar images are battling it out. A view of the Aurora Borealis, taken by astronaut Randy Comrade Bresnik, matches up with stargazers from the ISS. Which one will glow bright enough to move to the next round? This one might be a toss-up. The winner will either face the Cleveland volcano caught in the act of erupting, or another stellar image, Stars in Motion. So, who do you want to win? At the moment, there's a 50% chance that we will see a number 8 seed in the last round, and a 75% chance that we'll be seeing stars in the finals. But hey, you decide. Vote at earthobservatory.nasa.gov/TE, where you can also read about all the amazing images in the tournament. Happy voting!
Photography is challenging. You have to know the proper settings and tools for your camera. You need to zoom and focus and adjust to the lighting. Now imagine trying to shoot photos from space, in a microgravity environment, while looking out a window and flying faster than 17,000 miles an hour.
Photography can be challenging in any environment. To be able to understand the optics, be able to understand aperture, and to be able to get the right combination of that to get the shot that you're after. It's particularly challenging in space because of the dynamics of it.
In the 20 years that astronauts have lived on the International Space Station, they have shot millions of photographs. They record life inside the station. They take detailed views of equipment and experiments. And they capture views of Earth nearly every day. Photography is not just a hobby for the ISS crew. It's part of the job, and one they need to be trained to do. The challenges of shooting photos from space are many. sun rises and sets every 90 minutes, landmarks move from near to far in just seconds.
For orbiting the Earth every 90 minutes, going 17,500 miles an hour, if you are targeting a specific location on the Earth, you have to be in the window and ready for it when it passes underneath. It's not going to wait for you.
The process of getting those shots starts years before an astronaut ever sets foot on the station. At Johnson Space Center, astronauts are trained to be photographers. Their tools are no different than what we use on Earth: handheld digital cameras and video equipment. In the classroom and in the field, they get basic photography lessons, skills classes, and lots of practice. Their teachers are professional photographers and videographers with 100 years of experience between them. Even with all of that training, there's nothing quite like learning on the job. The space station is orbiting, the Earth is turning, the sun is reflecting off of Earth's water, the station's solar panels, and even the thick multi-layer window panes. But once the astronauts get oriented, once they learn to steady themselves in the camera, well, then their perch may be the greatest any human photographer has sat in.
Everybody's favorite window was added in 2010. It's the cupola. I call it the window on the world. It's the only place on the space station where you can see the entire globe. We have photography equipment, cameras, and lenses staged throughout the station at the different window locations so that the equipment is readily available whenever we have a pass over something interesting and we have time to take some photography.
If the only purpose of shooting photos was relaxation or documenting life and work on the space station, then the astronauts would be all set. But looking at Earth is actually an important scientific job. And so the women and men of the Earth Science and Remote Sensing Unit train the astronauts in how to observe their terrestrial home.
We're trying to get them into the mindset of being able to look at a landscape, recognize what's out there, and more importantly, recognize what's anomalous.
In these classes, the Earth Observation Team teaches the astronauts key concepts in remote sensing, geology, ecology, mapping, climatology, and weather. They even go out for some field work.
We give them focused training on the kind of sites that we're going to be asking them to photograph from the ISS. Because an astronaut who has some understanding of why they're being asked to take pictures of these volcanoes or why we want them to take this picture of these glaciers leads to, one, they get more invested, they become more interested in why they're taking the images, but they also tend to take better imagery because they understand what it is we're actually looking for.
Not all of us have a background that would give us an appreciation for the spectrum of different types of things that you can see on the Earth. Part of the training is, what do the scientists interested in Earth observation look for? What are their interests? What kinds of phenomena? What geological structures, for example? What kind of changes are they trying to capture over time?
Scientists, geographers, and students from around the world submit requests asking for views of Earth's features and landscapes. Each day, a few of those requests are passed to the space station crew. The Earth observing team maps what the space station will be flying over on each orbit of each day, whether it will be daytime or nighttime, cloudy or clear. They work with other space station teams to see when photography might fit into the work schedule. And they provide guidance to the astronauts on how to spot their targets on the ground.
It's really difficult for us because you may be reversed, you may be oriented 90 degrees, but we also try to include images that are other astronaut photographs. So we try to give them that kind of situational awareness as much as we can.
From their orbiting home on the space station, the astronauts have a view unlike anything most of us will ever see. It's valuable because it's inspirational and because it's scientifically useful. So the astronauts and the ground team work together before, during, and after every mission to get the most out of every shot.